Hello everyone, today we are going to work on this adjusting system of the beam length. So as you can see here, this beam length is adjusted only until it hits some surface, so it doesn't penetrate this object as before. So we are going to use some line traces and do some relative scale and offset modifications in the runtime based on the hit result of that line trace today using C++. Right, now if I play the game, as you can see, this beam is penetrating this object. It doesn't cut off here, so that's what we want to avoid next. So for that, what I'm planning to do is doing a line trace and determine the point. If there is a point in between this along this beam, if there is a hit point, the size of this beam will be adjusted so that it will be shortened until that hit point, so it won't penetrate any of the objects. Right, so first we need to figure out how to adjust the length of the beam, this laser beam, to a given amount. At the moment, if I go to the turret, the beam scale is 5 and location is 640. Actually, I think we can find out a relationship here. So let me go to the viewport and top perspective. 5, I think this would match minus. Oh wait, let's assign a different cube. This is from engine measures. This cube is in basic shapes. Let's assign that one. I think that one have better proportions. Minus 500 minus 250. Oh yeah, this one has better performance. So when I have the scale of 5, the location offset has to be 250, and 5 means in unreal units. We can measure this. (2,000 units). So when the scale is 5, we have a length 2000. So let me put that in a notepad. Length 2000 and scale, I'm just trying to find out a relationship. Scale is 5, offset is minus 250. So if the length is L, then the scale would be L divided by 2000 into 5. So that means L divided by 2000 into 5, that means L divided by 400, because 2000 divided by 5 is 400. Right, and this offset is scale into minus 50. So scale means L divided by 400. This multiplied by minus 50. So that's the simple relationship we can see here, we can observe here. So this will not, obviously this is not a universal relationship, because this depends on the dimensions of the mesh that you have assigned. So if you have assigned a mesh for this cube with different dimensions, you will have to find these values that matches the dimensions of your object. So let's implement this simple formulas in C++. For that, now we would need some more variables. So these are variables related to rotation. I just have to comment for your reference, for future reference. So here let's add wait. Oh, another comment here. So in between these two comments, I will add variables related to set the length of the curve, length of the beam. Actually, but we would need only one variable, and this has to be exposed into the details panel. So I'll add you property. I should be able to edit this anywhere, and also I should be able to access this in blueprints as well, just maybe for testing purposes. So I can't actually define this in private sector. I will have to define this in protected or public. If I define it in protected, only the child classes of this CPP turret will be able to access it. That means the blueprint is also, the turret blueprint also a child classes of CPP turret, so it will be able to access it. If I define in public area, any class that has a reference to this class or BPP blueprint turret class will be able to access it. But I think for now it's enough to have access in this protected level. So your property, edit area. I will need another specifier, property specifier, to make it accessible in the blueprints, but for now I'll just add this, and let's call this float beam length. The default value, let's say 1000. Right, and we need another function to set the length of the beam. Oh, this should be beam length. And I think it's having that function in private area should be enough. Function. This should be callable from, oh no, let's forget for now. So void set beam length, and we need a float parameter length. Right, so let's create the definition. Okay, let me go to that function. So according to the equation we found out here, if we need to set the length to L, that means we have to set the scale to L divided by 400. So actually this only applies to the X scale, because we only need to change the length. We don't need to change any other dimensions of the scale. So mesh we don't have mesh, just beam set relative scale 3D F vector. So we need to give this X vector. So the X scale would be length divided by 400. This hard-coded value is a loose end in this code, but for now I don't have any other alternatives, so let's just ignore that problem for now. And the Y and Z scales should be same as what we have at the moment. So B get relative scale 3D Y, keep the same value for Y and Z. B get relative scale 3D C. Right, now after we set the relative scale, we have to adjust the offset in order to make it plugged to this point. So for example, if I make it 10, you can see it exceeds this area. So if I make it 10, this has to be 500, see, minus 500. So B set relative location. This also needs to be an F vector. The X location is L divided by 400 multiplied by minus 50. That means this is same as L divided by minus 50, so minus 80. If I just simplify the function, so length divided by minus 50, that's X, and Y value is 0, Z value is 0. We don't need any other offsets for them because we are attaching it to the point of the beam socket. Right, I think that's all, but we need to call this function somewhere, and if I call it, so if we call this in constructor, that means here as we change the value of the beam length, this should be modified, but this constructor is not get called every time we make a change in our blueprint version. So just to see that, let me just set beam length and use beam length Oh, there is a typo. Yes, there shouldn't be any A. Right, now let me compile. Right, compilation complete. We should have beam length somewhere. Yeah, if I make it 500, you see the length is not changing. See, length is not changing. So that means this constructor is not getting called. But if I call that constructor here in the construction script, set beam length, oh, we can't call it. If I can call it, that would work, but still we can't call it because this function set beam length is we haven't defined it to be able to call from blueprint. So what we can do is we can define the property specifier blueprint callable. Right, now if I compile, I should be able to call it from here. Set beam length. Right, now we should be able to access this variable as well, this one, beam length variable, but we can't access it because I haven't given the rights. So edit anywhere, blueprint read. We can read only also would work, but I'll just call it read, use it read only. If I want, I can specify a blueprint read write as well, then I will be able to set the value from blueprint also, but I don't need that for now. So let me compile. Okay, now beam length. Now I can access the beam length variable. Right, now you can see this is getting adjusted, but it's not working properly. Why? There should be some problem in our code, the way we set the relative offset. It's not minus 50, it was minus 80. Yes, minus 80. Still not correct. Sorry, actually this is not 80, this is just 8. Really sorry about that, because 400 by 50 it's just 8. Okay, just a mistake. Compile. Why? Okay, 10,000. Alright, okay, it is working. See, so I can set the value let's test in here as well. If I make it 500, it's working. 5000, it's working. Okay, cool. So we can adjust the length to whatever the length we need. Right, now we have this function where we can set the length of the beam dynamically. Next thing we have to do is doing a line trace in the runtime to determine if we hit any other objects, so that we can adjust the length of the beam dynamically. So for that, let's add another function, a private function. Void trace beam. Let's call it trace beam because we are going to do a line trace. Let's create the definition. Right, so here what we have to do is doing a line trace. So in order to do a line trace, let's see the function, how it looks. So we need out hit, a hit result, and starting point, end point, and we need to define the trace channel, and we need collision core parameters. This is also passed as the address, and response parameters. Okay, so included in the world edge, so I don't think we need to do any additional in header files. We don't need to add any additional header files, so everything should be there. Right, so first thing we need is a hit result, f hit result. F hit result, hit result, and what else? We need start points and end points. So vector start point is the target mesh, get socket location, socket name is beam socket. Let's check to be sure. Oh, if you don't remember, this one, beam socket, this is the starting point of the trace, and also it is already inside this object, so we will have to ignore the self object in the line trace as well, which we can do with collision parameters. That's the start and end vector end. End would be starting point plus forward vector of the beam. Beam, actually it's backward. Forward vector is this way, so if I make it 180, forward is this way. Right, so start plus beam get forward vector into into the length, beam length. So this is the maximum length of the beam can be. Right, what's next? And collision channel, for that we can just define it, we don't need a structure. And this collision parameter and response parameter, I think those two are optional, but we need collision parameters because we need to ignore self factor. So if collision query params query params, so we need to ignore this actor. So all query params and ignored actor this. Right, now we can do our line trace, and we need to have a boolean variable to store the result, because we should get a true if we hit something, otherwise we would get a false, and we need to know that. So we hit equals get world line trace single byte channel. Initial parameter would be hit result. Let's define it like this. So actually this is hit result is an out parameter, so let's make it explicitly noted by doing a hash define out. For the compiler this doesn't matter, this is just for us. Out hit result. Next is start, end, and then collision channel. Collision channel ECC camera channel should be fine for this, and collision query parameters. Right, so that's it. The reason I typed it one by one is to make it more clear. If I type it in a single line, it's not very clear. Right, so if the hit is true, that means we have a hit object. So we need to adjust the beam length. Set beam length with hit result. We have distance. So from this variable we can access the length of the line trace until the first hit point. Right, so if we don't have a hit, set beam length with the default beam length, and I think that's all. Oh wait, we need to call this trace beam in our take. And it may not be necessary to call this in every frame, so maybe if we move this into a timer with let's say called like 5 times in every second, something like that, should be also fine. But let's first test and see if this works. And to see the penetration, I'll make it longer. Right, comparison done. Let's play, and you can see now the beam is no longer penetrating this object. See, it's adjusted its length to the distance until the hit point. Let me add few more objects to make it more clear. So it is working as intended. Now let's see if we can move this into a timer instead of calling that in every frame. So let me comment this. So I think we need a new timer handle. I'll name it trace timer handle. Let's rename this to a more meaningful one. Instead of timer handle, target timer handle. Right, now we can get third timer manager, set timer. Why shouldn't I don't get the suggestions because this is running. Why not just copy this and change only what I need? That's fast. Trace time. Trace. Still don't get it. Trace B. Delay should be, let's try 0.1 F. And initially there should not be any delay, so 0.1, and it should be looping. So right, let's compile. Right, compilation done. Let's test it. Seems good enough. 0.1 second delay timer seems good enough, rather than calling it from every frame. Okay, so I'm gonna stop this episode right here. Next time let's work on if this trace detects a character, let's say player character, it should start shooting at that character. Let's see how to do that part in next episode. And thanks for watching. As always, project files will be available in the Patreon page. Link would be in the description below, and if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.